Hello, lovely people. It's amazing weather in the UK, as always at this time of the year. Anyway, today we will be talking about some power supplies. So since I started to measure all the amplifiers and DSPs, I needed some kind of a power supply. So I was using my lithium bank and I got some extra stuff. So this one was featured in a previous video by Crown Customs, a very cool lithium battery. Go check it out. And here I have some other power supplies. So why do I want to test this? Because that lithium that I have is very, how should I say it, bulky and very inconvenient because it's heavy. It's a mess anyway. So I wanted something like a cleaner option. And I want to see which one of these is going to provide me with the cleanest DC. Now, obviously, it's going to be the battery, but battery is heavy and it's difficult to, it's not difficult, but it's just annoying to connect all the wires and everything and that kind of stuff. And I have these power supplies. So these two are what you call the switching power supplies. And this is a linear power supply used for a radio. So I got this on Facebook Market. And again, thank you to my Patreons and people that support me directly via PayPal. I'm going to leave the links in the video description. And if you want, you can support me so I can buy some cool stuff. So I bought this locally on Facebook Market, and it is a regulated DC power supply. It's very, very old. It's like from the 90s or probably the 80s. This is supposed to be much cleaner than a switching power supply. So let's actually talk a little bit about power supplies. So this is a battery charger that has a built-in power supply option, and it provides on power supply 13.8 volts and 25 amps max. And inside, it's a switching power supply. So it is supposed to be kind of better than the cheap Chinese ones. So this is a cheap Chinese one. It is a 40 amp power supply, and it is a regular cheap switching power supply. These are the internals. There's literally nothing. This cost me like 12 pounds from AliExpress. And since it's a cheap one, like over the years, the circuitry probably improved, maybe the components kind of improved, but a lot of people say that in these cheap power supplies, they reuse the components. So the components are not brand new. They could be like out of tolerance and everything. And it's kind of a dirty power supply. So it is kind of fine to charge the lithium and maybe for something else. But I want to see how much a dirty power supply can influence the measurements that I do with the DSP. So this is, for example, we have some, I don't know the circuitry, but it's like you have some MOSFETs that basically switch on and off and will give you a constant DC voltage. So if you want the higher voltage, they're going to switch much faster. If a lower voltage, they're going to switch a bit slower. And that switching of the FETs introduces noise because it's like on, off, on, off, on, off, and you have peaks and stuff. So similar to this, like circuitry or whatever you have in power amplifiers, like in car amplifiers, class D and whatever, you have switching power supply where you have a transformer that steps up the voltage, and you have, where is it? Some like rectifiers. To be honest, I don't know where things are, but I know that it's kind of similar circuitry. And then basically AC comes in and AC comes in here and DC goes out there. So this is a switching power supply. And that one's supposed to be same like topology switching, but should be better because this one cost, as I mentioned, like 12 pounds. That one costs like brand new, it costs like 200. I got it much cheaper because I bought it used. And now we're gonna go to the linear power supply. So I did take it apart for you to have a look. You can see inside it's very old, all dusty and everything, but it doesn't affect anything. And it has this massive transformer. So instead of the switching, the FET that is switching, this transformer actually supplies all the current. And depending on, like, I think these will regulate the actual voltage because it is adjustable from 0 to, I think it goes up to like 15 volts. We're gonna have a look. And we have a current meter as well. So it is bloody heavy. It has a heatsink in the back, and this transformer is very, very, very heavy. So like if you compare a switching supply and this one, so this is 20 amp, this is 40 amp, and you can see the size difference and the weight difference, and obviously the price difference, because brand new they were very expensive. So this was used to power like a radio. I bought it locally on Facebook Market, as I mentioned, from a guy that's like very, very into radios, and he has plenty of these. This gets hot, and it is a passive cooling, so it doesn't have any fans or anything, so it does get hot if you run a lot of current through it. And this has an active cooling, so it has a fan, a built-in fan, and exactly this one as well, it has a fan. You cannot see it. Basically sucks air from one side and expels from the other. It has a fan as well, so it is kind of noisy. However, this is dead silent, dead quiet, and obviously a lithium battery. So what I'm going to do is I'm going to try to match the voltage. Now, I'm not going to match this one because this is going to be like 13.3. Actually, we're going to have a look. Let's have a look. DC, negative, positive, there we go. And we have 13.28, so 13.3 volts. Now these are adjustable, so I can adjust them to match 13.27. However, that one is going to be 13.8 because that one I cannot adjust. So I'm going to adjust these to the same voltage. Actually, we can do it now. Okay, so I connected positive, positive, negative, negative. Now I'm going to switch it on. Now it's working, and you can hear the fan. And we have 13.3. So with this one, all of these power supplies have like this pot. I was painting. It's not emo. I was painting. So it has these pots, and you can adjust by turning it one way or the other way, and it goes from 10 volts. And if I switch it, it increases all the way up to almost 15 volts. So we need to match it to have 13.27 something, just to have, there we go, perfect. Or 13 or 12. 13 to 4, now it's gonna be fine. So 13.24, matching to this. Now let's do the same with this one. Okay, this one, it's plugged in, and now I'm gonna turn it on. Comes on to light, so it's all the way, there we go. So this, for some reason now it's not working. It was working, but it was not accurate, so I had to pull it out and do some I wanted to like calibrate it, but I did notice that it's even after the calibration it was not accurate. So like 13.8 it was showing fine, but then it's like volt or 2 volt difference. So this one for me doesn't matter. I'm gonna trust this. So this has a knob, and it goes down and up. So it goes all the way down to 0 volts and up to 15.6. So more adjustability. So we're gonna try to find 13.2 something. There we go. Perfect. 13.25. So this is spot on. So all of these three are gonna have the same voltage. Now this one, let me show you. Okay, so now I have this one plugged in. I'm probing this, and I'm gonna switch it, turn it on. So first it goes on to like charging mode, regular battery, and we have nothing. We switch to the supply mode, and it gives me 13 point something. It might be these. There we go, 1375 volts, which is close to 13.2, half a volt more. So I think it's gonna be not a bad comparison. So we have 4, and just for shits and giggles, I got this one as well. So this is, again, power supply. How much it does? 3 amps. So for a DSP, it's gonna be perfectly fine, adjustable from 3 to 24 volts. Let's adjust this one as well. Okay, so it's on, and this one goes from, oh, it's blinking, 3.56 all the way up to 24.8, so basically 25 volts almost. Let's find 13.2. Let's go down, see how accurate it is as well. 13, a bit higher. Oh, it's very sensitive. A bit more. There we go, 13.3. Ooh. 13.3 and this one shows 13.4. So yeah, that's perfectly fine. So I will be testing 1, 2, 3, 4, 5 power supplies and see which one is going to be the cleanest. Now, obviously, I think this is going to be the cleanest. This should be second, then this, then between these two, we will see, but I think these are going to be the worst with loads of noise. So to test this, I'm not sure if I'm going to use these because they're bloody expensive. I don't want to break anything. I might use my audio Scarlett audio interface with a voltage reducer because I need to bring down the voltage from 13 volts all the way up to like down to below 1 volt. So I might use the reducer with that. And first we're going to measure the DC straight from these things. And then I'm going to connect Helix DSP and we're gonna play some probably sine tones and see if there is a difference between these, because like all the equipment that is built ideally should account for noise in the system with these. However, car stuff, they're supposed to be run from battery, obviously with an alternator, but still from battery. So we will see how much noise is going to induce. And then I'm going to decide with which thing I'm going to do all of my measurements. Okay, so I did some measurements already, and from these measurements, it's obvious that I'm not gonna need to measure the actual DC on each supplies, because everything that goes from this DSP, it's so obvious, and obviously we're gonna have a winner. So I wanna show you very quickly how I do this measurement. I have the topping connected on analog into the DSP, because from the previous test, you saw that on digital, the noise kind of goes away. And specifically for this test, I want to keep the noise. I need the noise to see how it is bigger or smaller. So on analog and analog out into the AD converter and into the laptop. So on this, I'm gonna, there we go. So with this, the only thing that I did, I increased the FFT length so to 512. So it's gonna be like dig deeper into the noise floor. And from one sweep, I determined that this DSP is the cleanest at -6 dBFS. So I planed this -6 dBFS tone. At the moment, I have this one connected, the worst one. And then if I click on this, I have to wait a bit because with this buffer, see, it kind of takes a long, because it's 512, so it takes quite a long time to settle down. I'll wait for about like 30 seconds or so, and you can see it's settling down. And it is like this. Okay, so now I discovered something very, very weird. Because, so I did measure this one. As you can see, it's full of noise, full of noise. However, I did all the measurements with the laptop disconnected from the mains. So this is disconnected, this one, and you see there's loads of noise. If I plug the laptop into the mains and I reset it, the noise goes away. What the hell? So this is very interesting, because I thought like the laptop might introduce something like 50 Hertz or something, but so probably it has to do something with the ground, but this one doesn't have a, or did it get, yeah, it has a ground. But the laptop doesn't have a ground because it's only two. This is weird. Okay, if anybody knows why this is happening, please comment below, because this is screwing up all my measurements. Because I did, and I determined that this is the worst, but it's not that bad if you connect it with the laptop. Okay, so let me run through, again, all the measurements with the laptop plugged in. This is interesting. Okay, so I rerun all the measurements with the laptop plugged in as well, and it is very, very surprising. So let's start from this. This is lithium, and we have -98 dB. So I'm checking, the only number that I'm checking is the THD plus noise. Where is it? This one. THD plus noise on all the measurements. 1 kilohertz tone, same level, same everything. The only difference is, again, just the power supply feeding the DSP. And as I mentioned, it's on analog signal, and everything is, it is what it is. So that's the lithium, -98. The linear, the second one, the linear power supply that I was thinking is going to perform the best of the bunch. You can see it has some harmonics, especially the 50 Hertz, which is weird, and some extra harmonics. But these harmonics are quite low, So this we can say that it's the actual DSP and not the power supply. And the power supply is basically all of these harmonics at like 150, 250, and so on and so on. So these are introduced here. The difference between lithium and the linear power supply is half a dB, which is basically nothing. But obviously lithium is much cleaner. The interesting thing is that on lithium, I have this at 50 hertz. So 50 hertz in the UK is the mains frequency, and this is laptop is plugged off, so it's not in the mains. So basically with this testing setup, absolutely nothing is connected to the mains. So the question is, what gives me this 50 hertz bump? And I did try on the linear power supply. So I was thinking this is, okay, so this is the actual mains, the 50 hertz. And in Helix DSP, there's a switch to lift the ground. And the switch goes GND ground, it goes 200 ohms and ISO. And I tried all of these three switches and it doesn't change anything. Weirdly enough, it's exactly the same, 97.5 dB, 97.5, 97.5. Basically, there's no difference between. Some difference you can see here, some weird stuff happening, but like at the lower, it doesn't affect anything. So my thinking this, I don't know, this 50 hertz, if anybody knows why I have a 50 hertz bump with nothing connected to the mains, please comment below, because to me it looks like something with a DSP. Anyway, linear, good, half a dB. Now the other thing that I tested, the 40 amp Chinese power supply, that's like 12 pounds. And let's compare it to, again, to the lithium. We can see harmonics as expected, however 96.9. So it's not that much. It's like 1.1 dB more noise. So you can see that noise, obviously it's more, but it's so low in the noise floor that, yeah. And if you compare this one to the linear, there's very little difference. You can see very little, a little bit more here, but very little difference. So the surprising part for me was that this 40 amp Chinese power supply is as clean as the linear power supply from the 90s. It is a bit, the linear is a bit more cleaner, but not much. Then the surprising one again, I tested the C-Tech. So the C-Tech is the actual battery charger that is not supposed to be used as a power supply, but it has a power supply mode. But this one has a lot of noise. So extremely a lot of high frequency noise. And the THD plus noise is 77. However, as I mentioned, so 50 hertz, again, massive bump. I did notice that if you, so this is without the laptop plugged in. If I plug in the laptop, this C-Tech goes down like that. So probably all this noise is going to ground through the laptop charger or something like that. But it's still, it goes to minus 90.1. You can see still a lot of noise. And here, at what, 11K, there's loads of noise here as well. So C-Tech with the laptop plugged in and unplugged. Exactly the same with the cheap 24 volt adjustable that I bought like literally for a few pounds. Again, same situation, loads and loads of noise, minus 76 dB, THD plus noise. As soon as I plug the laptop in, all of that goes away, just like that. Why? I have no idea. But the surprising part is, this one, the cheapest one that I have, is 96.6. So it is almost as clean as that linear one. Again, more noise, but not 1 dB more. So yeah. So the thing is, like, for DSP testing, this linear, yeah, it's not the best because it has, compared to lithium, it has some harmonics. Okay, so to summarize very quickly, the C-Tech is garbage for testing amplifiers and DSPs, and obviously it's not designed for that. It is a battery charger after all. So battery charger is a no-go. This 40 amp power supply from China, very, very cheap, plugged in and off, good. It has some harmonics, but is as good as the linear. And this one, the small one, it's not bad. Like to test DSPs, it's very convenient because it's very small. So you just literally just plug it into the wall, and it's very small. It doesn't take up space. 3 amps of current, plenty enough. But again, test DSPs, not really. Amplifiers, yes, but for amplifiers, you need more current. So this goes out. So now I have 2 options for testing amplifiers. I have the 40 amp and the linear. So again, for testing DSPs, it's not good because it has some noise, but for testing amplifiers, which are gonna have much more floor noise and everything, I think this is gonna be good. And probably I'm gonna do a test as well with one of the amplifiers, just to see how big of a difference it is between the lithium and linear supply and this 40 amp supply. Because like lithium is gonna give me the most amperage, but between these, this linear is 25 amps max, this one 40 amps. So to test like 4-channel amplifiers, it's not gonna be enough anyway, so I will need to use lithium. But yeah, so this test just showed me that even the linear power supply is not good enough to test DSPs. You need a very, very clean power supply, and in my case, it's gonna be a lithium battery. So yeah, I might test amplify smaller ones with the linear or this 40 amp, because it's just more convenient than dragging an actual battery around. But for everything else, it's gonna be lithium. Lithium. Yeah. Battery is the cleanest. So it's kind of common sense, but it's very fun to see in all of these measurements. So yeah, thank you very much for watching, guys, and I will see you in the next one.